Hello class, we are going to look at part 3 of our notes on exploring graphs of quadratic functions. Today we'll be focusing on quadratic functions that are in standard form. So today we're going to understand standard form. Our learning target says I can calculate key characteristics of the graph of a quadratic function. We want to calculate, keyword calculate, these key characteristics. Today we're going to have to use some formulas. Okay, so if we'll look at this example, we see f of x equals 2x squared plus 8x minus 2. We know that this is in standard form because we have ax squared plus bx plus c. Standard form is ax squared plus bx plus c, where a, b, and c are some numbers. Okay, so we're going to find the following. We're going to find the vertex, the axis of symmetry, the maximum or minimum value, the domain, and the range for this function. We're actually going to begin with part B, axis of symmetry. There is a formula that you wrote down on part 1 of your notes for axis of symmetry that says x equals negative b over 2 times a. So what we will do is use our a, b, and c from the quadratic function in standard form and substitute our b and our a values into this formula. So from this particular quadratic function, the value of a is 2. That's the coefficient of x squared. The value of b is 8. That's the coefficient of x. And the value of c is negative 2. We're not actually going to use c today in this formula, but we will be using it very soon. Okay, so negative b over 2 times a. b was 8, so we're going to substitute negative 8 over 2 times a is 2. So now we're just going to evaluate that 2 times 2 is 4, and negative 8 divided by 4 is negative 2. So we can say that our axis of symmetry is x equals negative 2. Well, in notes part 1, we learned that the axis of symmetry is the x-coordinate of our vertex. So that tells us that our x-coordinate of our vertex is also negative 2. We're going to have to find the y-coordinate of the vertex. Now, we learned that the y-coordinate of the vertex is going to be the maximum or minimum value. This particular parabola is positive in the front, which means it's smiling. So therefore, this particular quadratic function has a minimum value. So we're not calculating a maximum, we're calculating a minimum value. Okay, in order to calculate the minimum value, we're going to go back to the original function, and we're going to replace our x, or substitute our x, with what we found to be the axis of symmetry. So what we're evaluating is f of negative 2. Negative 2 is the axis of symmetry. We substitute in that into the function in place of x. So 2 times negative 2 squared plus 8 times negative 2 minus 2. Now your calculators are actually smart enough to type the entire this entire expression in and give you an answer. But I will explain using the order of operations today. Okay, so we have an exponent that needs to be simplified first here. Negative 2 squared is negative 2 times itself, or 4. So this simplifies to be 2 times 4 plus 8 times negative 2 minus 2. Now I want to do my multiplication after I've evaluated the exponent. So I see multiplication in 2 times 4, which is 8. I see multiplication in 8 times negative 2, 8 times negative 2 is negative 16. Sorry, negative 16. And then I'm just going to bring down my minus 2. Last, I can perform this subtraction. 8 minus 16 is negative 8. And then subtract 2 from that, I get negative 10. Okay, so this is going to be my minimum value is negative 10. When I find that minimum value, I know I've also found the y-coordinate of the vertex. So the y-coordinate of the vertex is also negative 10. Now, let's talk about domain and range. If I flatten any parabola to the x-axis, it's going to completely cover the x-axis. So my domain, every time, is going to be all real numbers. For range, we're going to have to do a little bit of thinking. So I'm going to draw a sketch. There's my x and y axis. If I have a vertex at negative 2, negative 10, maybe it's about right here. Negative 2, negative 10. And this thing is smiling, we determined. So if I were to flatten this thing flat to the y-axis, this point would move all the way over to the y-axis, and the arrows are pointing upward. What portion of the y-axis would be covered? Well, the minimum value is negative 10, and then the arrow indicates it goes up to infinity. So negative 10 to infinity is the range in interval notation, or we could say all the y values that are greater than or equal to negative 10. Okay, let's look at the next example. Again, we have a function that's given to us in standard form. We're going to start by calculating the axis of symmetry. X equals negative b over 2a is our formula. In this case, a is the coefficient of x squared. Since there is no number in front of x squared, it is assumed to be 1. B is the coefficient of x, that is 2. And c is 3. Substituting into this formula, negative b is going to be negative 2 over 2 times a, which was 1. Simplifying, negative 2 over 2 times 1 is 2. And dividing, negative 2 divided by 2 is negative 1. So we have an axis of symmetry of x equals negative 1. That also is our x-coordinate of our vertex. To find the maximum or minimum value, we're first going to consider that this is positive in the front. It is smiling. So again, we are going to have a minimum value, not a maximum. And we're going to substitute into the original function the axis of symmetry that we found, f of negative 1. So we substitute negative 1 squared. Let me make a special note here. It is very important that you use parentheses when you're substituting into this formula. If you leave out parentheses here and you use your calculator is not going to understand this properly, and it is going to give you a wrong answer. So please, when you're substituting for x, please substitute in parentheses. 2 times negative 1 plus 3. Okay, you can type this entire line in a calculator or evaluate with the order of operations. Negative 1 squared is 1. 2 times negative 1 is negative 2. And then we're adding 3 to that. 1 minus 2 is negative 1. And negative 1 plus 3 is 2. So our minimum value is 2, which is also our y-coordinate of the vertex. For domain, all real numbers every time. For range, let's consider a sketch. Here's my x and y axis. If my vertex is at negative 1, 2. So let's say here's negative 1, here's 2. Here's my vertex. And we already determined that this parabola smiles. If I flatten this thing to the y-axis. That point moves over here to 2, and then those arrows are all pointing upward. So my range would begin at 2, and then it would go up to positive infinity. Or we could say it's all the y values that are greater than or equal to positive 2. Okay, next example. Again, we're going to begin with axis of symmetry. Formula, x equals negative b over 2 times a. Our a in this problem is negative 3. Our b is negative 4. Our c is 6. So if I substitute in negative b, that's going to be, this time, negative 4. Okay, there's a negative in the formula, and there's also a negative on b, so that's minus a negative. Over 2 times a, that's going to be 2 times negative 3. Okay, minus a negative becomes positive 4. 2 times negative 3 is negative 6. I get a reduced fraction of negative 2/3. You can reduce this on the calculator, or you can see, 4 and 6, they're both even, they're both divisible by 2. 4 divided by 2 is 2, 6 divided by 2 is 3, and it's negative. So our x-coordinate of our vertex is negative 2/3, and our axis of symmetry is x equals negative 2/3. Yes, it's okay to get a fraction. For the maximum or minimum value, first let's consider, is this a max or a min? Well, I see a negative in the front, so this thing's frowning. When it frowns, the vertex is at the top, meaning this is going to be a maximum value. So we have a maximum value, and we're going to calculate it by substituting our axis of symmetry, negative 2/3, into the formula. So we're going to say y equals negative 3, and I'm changing all the x's to parentheses first. Replace all x's with parentheses, and inside those parentheses, let's input negative 2/3. Okay, this one's pretty ugly, so why don't you take a moment to substitute this into your calculator and see if you can come up with the correct y-coordinate or maximum value. Pause the video. So when I input this into my calculator, I got y equals 22/3. So we got a maximum value of 22/3, or 7 1/3. Okay? So my y-coordinate of my vertex is 22/3. All right, for the domain, our domain is all real numbers. For the range, let's consider a sketch. If I plot my vertex at negative 2/3, 22/3. I plot a point here and I show a parabola that's frowning, and I were to smash this flat to the y-axis, the vertex would move over, everything's pointing downward. Our range, remember in interval notation we're going to give the least to greatest. Our least would be negative infinity, and our maximum value is 22/3, or 7 1/3. Another way we could say this is all the y-coordinates that are less than or equal to 22/3. For this example, I would like for you to take a few moments, make an attempt at this on your own papers, see if you can go through all the steps, calculate the axis of symmetry, calculate the maximum or minimum value, then give that order pair for the vertex, state the domain, and state the range. We'll pause the video now and give you time, and then we'll play to see the result. So here are the answers. The vertex 1/2, -9/2, or 0.5, -4.5. The axis of symmetry, x equals 1/2, or you could have said x equals 0.5. This had a maximum value because it was frowning. Maximum value is -4.5 or -9/2. Domain, always, is all real numbers. And here's the range, -infinity up to -4.5, or all the y values that are less than or equal to -4.5. So I hope that you did well with this. I hope this helps you understand how we can find all the key characteristics of the graph of a quadratic function from standard form. Good luck on your assignment.